Hi guys, this video is for those of you who need help solving systems of linear equations. At any time during the video you can choose the specific method you're having trouble with by clicking on the links below, or just hit the start button to see all three methods. The directions say, solve the following system of equations by graphing. And that's what I want to do. So I want to get each of my lines to look like y equals mx plus b, so that it's really easy to graph them. So really I just want to get y by itself. So in the top line, all I need to do is move x over. So I have y equals negative x minus 1. And then the second line, I need to move x over. I'm going to have to write this one out. Let's see, x minus 4y equals 24. So I need to get y all by itself over here. So I need to move the x over. So I have negative 4y equals negative x and a positive 24. And then to get y alone, I need to divide by negative 4 everywhere. And then so that's y equals, now a negative over a negative is positive, and the coefficient in front of x is really 1. So this is really 1/4 x. And then positive 24 over negative 4 is negative 6. So these are the two lines that I'm going to graph. So whenever you go to graph a line, you always start with b. B is the y-intercept, so that's the number on the end. So in my first line, it's negative 1. That tells me that if I look on my y-axis here, my first line is going to cross at negative 1. So that's where my first dot is going to go. Now this is probably not going to be real pretty, guys, so y'all just bear with me. And then I look at my slope. That's the second thing I look at. That's what m is, and that's always the number in front of x. Well, in my first line, my slope is, it's actually negative 1. And remember, slope is rise over run. So in the first line, my slope is really negative 1 over, and I can just make it into a fraction if I put a 1 there. So negative 1 over 1. Now if my rise is negative, that tells me to go down, and if my run is positive, that tells me to go to the right. So from my first dot, which was here, I'm going to go down 1 and to the right 1. And that's where my second dot is going to go. Right in here. Now I can continue that trend on and on and on, and that'll kind of show me what my line is going to end up looking like. Yeah, I can't draw very well on this thing, so. But that's basically it for our first line. Now, for our second line, let's do the same thing. So again, what is our y-intercept? Negative 6. So that's where my first dot goes, on the negative 6 on the y-axis. And then we come back, and look, our slope is 1 over 4. So remember, slope is rise over run. So I rise up 1 from where I am and run positive 4 from where I am to the right. So from that negative 6, I go up 1 and over 1, 2, 3, 4. So that will be where my second dot is. So I'm going to do my best. I can actually follow that trend backwards and put a third dot if I want to. So I can get a good line. Ooh, this is going to be ugly. But generally, that's my second line. And if I'm solving the system of equations by graphing, the answer is always the coordinates, the x and y coordinates, of where the two lines cross. So I just have to identify, well, where's that spot? What is the spot where they cross? And it's not real pretty, but it is right in here. So if I look, the x value is 4, and the y value is negative 5. And that's my answer. Let's do another one. Okay, the directions say again, solve the following system of equations by graphing. We're going to do the same thing again. We're going to get y alone for each line. So in the first one, 2x minus y equals 6. So I'm going to move the 2x over, and I'll have negative y equals negative 2x, because remember, when we move stuff over the equal sign, it changes sign, plus 6. Now y is not quite by itself. It's still got that negative 1 there next to it, because that negative is actually what the problem is. So I divide everything by negative 1, so that now that negative is gone, and I have y equals negative 2 over negative 1 is positive 2x, and then that's a minus 6. So there's line number 1. And then the next one is 4x minus 2y equals 6. Again, negative 4x plus 6 divided by negative 2 to get y alone. Y equals positive 2x minus 3. There is line number 2. Now let's graph. Okay, I always start with the y-intercept, negative 6. So I go down to negative 6, and that's where my first dot will go. So then I come over here and look at my slope. Well, it's 2. So remember, a slope is really a fraction. So I can pretend this was 2 over 1. So I go from where I am, I go up to 1, 2, and over 1 to the right, because they're both positive. So I go positive directions both times. So that's where my second dot goes. Up 2 and over 1. So there's dot number 2. And I can keep doing that, up 2 and over 1, up 2 and over 1, up 2 and over 1. The slope of the line never changes. I could go down 2 and over 1, as long as I go over in the other direction. So there's what my line looks like here. Alright, let's graph the second one. So negative 3 is where it crosses. So on the y-axis I come down to negative 3. There's my first dot. Now here again I look at the slope, and it's really 2, but hey, we can make that a fraction, 2 over 1. So I go up 2 and over 1 from that negative 3. So up 2 and over 1 would be here. Up 2 and over 1 again would be here. Up 2 and over 1 would be here. Here. And again, I can go down and over the other way, down and over the other way, down and over the other way. Look what's happening here. This one's kind of a trick question. The whole thing is that the solution of this system is supposed to be the x and y coordinates where these two lines cross. But look at what happened here. They didn't cross at all. And the reason for that is that there are parallel lines. How do I know they're parallel? Well, take a look at the slopes. They're identical. This slope is 2. This slope is 2. And parallel lines never ever cross. Parallel lines always have the same slope, which means they'll never ever cross. So this actually has no solution. The directions say solve the following system of equations by substitution. So let me go ahead and talk about the whole idea behind this method. What substitution says to do is you take either this line or this line, and the idea is to either get x or y completely by itself. You want to solve for one of the variables, and you use that as your substitution rule. I typically don't use this method unless it's a problem like this, where y, like for instance, in one of the equations, one of the letters is already isolated on one side, so it's really easy. This is my substitution. It's kind of like I like to equate this to, let's say, players in a baseball game. This is my baseball, it's kind of weird, but this is my baseball game here. X plus y equals 12. That's the first equation. And the other one becomes your substitution. So again, with the baseball game, let's say this is player, this is the first baseman, and he gets injured and he needs to come out. Well, this guy plays the same position and he's sitting on the bench. Because y is the same thing as 2x, he plays first base too. So he would go into the game at the same place the y was playing. So basically the 2x gets substituted in where the y originally was. So I rewrite the first equation with the y substituted in. X plus 2x equals 12. And then I can solve that. If I just look at this thing. So just look at just this equation. What's x plus 2x? Well, that's 3x. And I can get x by itself. X must be 4. Now I get all excited when I get an answer and I think I'm finished, but remember I'm not. The answer to a system of equations like this is always an ordered pair, an x and y. So I actually have my x value. I won't always get x first. Make sure you put them in the right place. Sometimes you get y first. It just happens. But in this case I got x first and it's 4, so I have to find y. Now what you want to do is, I was working with the top equation up here, but now I want to work with the bottom one. I want to use the information I have to find y. So the bottom one says y equals 2x. Well, I know what x is now. Y is 2 times x, and that's 4. So y must be 2 times 4, which is 8. So there's my answer, 4, 8. So let's do another one. The directions say, solve the following system of equations by substitution again. Now, when I look at this problem, I don't want to work it either. I understand. There's fractions here and here and here and here and here and here. I mean, there's fractions everywhere. So we're not going to panic about it. We're just going to get rid of them. And here's how we do that. In the first line, let's just take a look and see what we have on the bottom. We have a 4 and a 4 and a 2. Now I just need to get a common denominator among all three of those, and I'm going to act like I'm going to multiply by that common denominator, but I'm not really going to multiply by it yet. I'll show you what I mean. My common denominator is 4 because I want the smallest number that all of the bottoms will go into. So 4 will go into 4, 4 will go into 4, and 2 will go into 4. So I know that's the best choice for a common denominator. Now I'm going to go ahead and find a common denominator for the second equation as well. I have a 2, a 4, and a 2, so actually again my common denominator is again 4. That's just a coincidence. It's not always going to be the same. And again, I'm acting like I'm going to multiply in the top, but I'm not really. I'm going to acknowledge that this is really a fraction where I can divide these out. 4 will go into 4 once. 4 will go into 4 once. 2 will go into 4 twice. Now let's go ahead and get rid of these. See, I'm dividing out the bottoms. 2 will go into 4 twice. 4 will go into 4 once. And 2 will go into 4 twice. Now all I have to do is multiply the numbers that I have left over. So in the top, I had 1 times 3 times x, which is 3x, minus 1 times y, just 1y, equals 9 times 2 is 18. So I just multiplied the numbers I had left over from my division. Now in the second problem, I have 2 times 1 times x, which is 2x, plus 1 times 3 times y is 3y. And then I have negative 5 times 2, which is negative 10. And now again, I wouldn't do substitution on this problem. I would do elimination if it was me, but this is teaching you substitution, so let's do it. So remember, substitution says get a letter in one of the equations by itself, and then that becomes your substitution. Now, when I look at all four of these letters, and there's two in each equation, I think the easiest one to solve for is this y, because really there's just a 1 by it, and I'm not going to end up with any weird fractions or anything when I solve for this, because there's nothing too bad to divide by except that negative. So this is the letter that I want to try to isolate in the first equation. So let's do that first. So I have 3x, I'm going to come down over here, minus y equals 18. So I'm going to pull the 3x over. That gives me negative y equals negative 3x plus 18. And then divide by negative 1 to get the negative away from the y. Y equals, now negative 3 over negative 1 is 3x, and then 18 over negative 1 is minus 18. This is, again, my substitution. Y is the same thing as 3x minus 18. Those two things are interchangeable. That's what equals means, is. They're the same. Now, since I used the first equation already to get my substitution, what I'm going to substitute into is the y in the second equation. Why did I pick y? Well, because that's the letter I got by itself. So I'm going to substitute into the second equation, 3 times y. Now what was y? I come over here and look. 3x minus 18 equals. So that's basically the second equation, but with that substitution. Now I just solve for x. That's all there is to do now. So I have 2x plus, now let's distribute, 9x minus, what is this, 54 equals negative 10. Okay? So let's add up our like terms on this side. I have 11x minus 54 equals negative 10. Let's get x by itself, so add 54 over here. 11x equals 44 divided by 11. So x must be 4. Now I'm not done, because remember, the answer is always an ordered pair, and it has to be in order. I got x first in this case, so I got the 4. Now remember, I have been working in the second equation, so to get the y value that goes with this x, I go back to the first equation and plug in for x. So it's actually right here. I'm just going to do it right here. So I have y equals 3x, which was 4, minus 18. So y is 12 minus 18, which is negative 6. Alright, I got my answer. The directions say, solve the following system of equations by elimination. So let's just start out by talking about what you want to happen with elimination. The word should give you a big hint. What you want to do is eventually be able to add these two equations together, add down. But we want to add down in such a way that either the x's here or the y's here become eliminated. Now, to make that happen, we need them to add to 0. So what we really need is for the coefficients, like let's say, for instance, we decided to get rid of x in this equation. I need the coefficients in front of the x in both equations to be a number that will add to 0, for each of them to be a number that when I add them together would be 0. So let's say the top one was 4. What do I need the bottom coefficient to be if I added to 4 to give me a 0 so that it would just go away? Well, I need it to be negative 4. So the whole deal is you need to, number one, pick an X or a Y that you want to get rid of. You pick which letter you want to get rid of, and then what you want to do is multiply one equation, or sometimes both, by a number so that when you add down, you eliminate that variable. So, since I've already talked about the x's, let's go ahead and choose to eliminate x. Now, again, I already have that the first x coefficient is 4 and the second one is 1. Now all I need is to multiply the second one by negative 4 to achieve that negative 4 right here that I was talking about. So now you can't just multiply one term. If you multiply one term in an equation, you have to multiply everywhere. That's why I wrote the 4 in front of the whole thing. So I want to multiply negative 4 everywhere. So I'm going to rewrite the top. Now the bottom would be negative 4 times x is negative 4x. Now minus 3y times negative 4 would be positive 12y equals, now I've got to do the 6 too, negative 4 times 6 is negative 24. Now let's see what happens when I add down. Negative 4 and positive 4, hey look, they had opposite signs, they cancel. So I add down here, that's really 1y. 1y plus 12y is 13y equals, now 11 minus 24 is negative 13. Now I have an equation that I can solve pretty easily. Negative 13 gets divided, and now see I have y is negative 13 over positive 13 is negative 1. So I have the first part of my answer. So remember, your answer is always an ordered pair. In this case, I got the y first, so now I have to figure out what x is. And all I have to do is take negative 1 and plug it in for y into one of my original equations. I'm going to pick the second one just because the numbers look smaller. So I have x minus 3y equals 6. It doesn't matter. It should work for both of them, so it doesn't matter which equation you pick. So I'm going to plug negative 1 in for y and then solve. X plus 3 equals 6. I need to get 3 over here. So x equals 3. And there I have my answer. Let's do another one. So again, the directions say solve the following system of equations by elimination. Now, as long as my x's and my y's and my numbers all line up, I don't really have to get it in standard form, but I like standard form. I like the way it looks, so I'm going to go ahead and I'm going to take the 5y and the 6y and I'm going to move them to the left side of the equal sign. So I have 3x minus 5y equals 13. I just think it looks better. And then 2x minus 6y equals 6. Now, in the last problem, I was able to multiply just one of the equations by something after I picked a letter to get rid of. And in this case, it's not going to work. And here's why I know that. If I look at the letter in front of here, the number in front of x and the number in front of this x, neither of these are multiples of each other. And the same goes for y. Neither of these are multiples of each other. So this really kind of has a trick to it. And here's the trick. Well, first I need to pick a letter I want to get rid of. It doesn't matter which one you pick. I'm going to pick x. I want to eliminate, so remember it's elimination. I'm going to eliminate my x's. Again, it doesn't matter. But what I'm going to end up doing is multiplying both of them by something. I need them to be the same number, but with opposite signs, so that when I add down, the x's are eliminated. It goes to 0. So the trick is whatever this number is, that's what you multiply the bottom equation by. And then, whatever this number is, that's what you multiply the top equation by. Now, you have to kind of take a look at your signs. If these have the same sign, they're both going to be positive when I multiply. If one of them was negative, I'd be okay. If this had a negative or this had a negative and they already had opposite signs, I don't have to add in that negative. But since they have the same sign as it is, I need to just make either the 2 or the 3 a negative. I picked the 3. Why not? Okay, so let's do our multiplication. So I have 2 times 3x is 6x. Let's do the top line first. 2 times negative 5 is negative 10y. And 2 times 13 is 26. So let's do the bottom. Negative 3 times 2 is negative 6. Negative 3 times negative 6 is positive 18y. And negative 3 times positive 6 is negative 18. Now I can add down to see if I can eliminate. So 6 and negative 6, oh look, that goes away. So negative 10 and positive 18 make a positive 8y equals 26 minus 18 is 8, positive 8. So let's go ahead and solve. Divide by 8 to get y by itself. And y is 8 divided by 8 is 1. So I have the first part of my answer. So remember, this is always an ordered pair. I've got my y first, which is 1. And to get x, I just plug in 1 for y into either of my original equations. It doesn't matter which one you pick. I like the second one because the numbers are smaller. So 2x equals 6y plus 6. But y was 1. So now I will solve for x. Let's clean up this side. 6 times 1 is 6 plus 6, which is 12. And then so divide by 2, x equals 6. So now I have my final answer.